So we're going to be looking at rate of change and slope, and hopefully by the end of this lesson you'll be able to find the rate of change from a table as well as find the slope and potentially be able to do that for a real world situation. So first we're going to look at, does the given ordered pair, is it a solution of the equation? So in order to do that, remember we substitute these values in. This is our x value, the second one is our y value. So we'll have 4 times 75 hundredths plus 2 times 0, and 4 times 75 hundredths is 3 plus 0 is 3. So yes, this is a solution. And then our second example here, y is equal to 6x minus 2. Again, we're going to substitute in. So we'll have 2, 6 times 0 minus 2. Then we'll simplify. Because 2 is not equal to negative 2, this is not a solution. Just a quick refresher on solutions. All right, we have two vocabulary terms that we're going to be looking at. The first one is rate of change. Okay. Rate of change is a ratio that shows the relationship on average between two changing quantities. So you can have a rate of change for many different situations. It can be for a graph and a function, or it can even be, right, you can have a rate of change for prices and things like that. The slope is used to describe the rate of change. Because a linear function is going to have a constant rate of change, any 2 points can be used to find the slope. And we'll look at what they mean by that a little bit further when we get to some of the examples. But rate of change is showing a relationship between changing quantities. Slope is a value that's used to describe the rate of change. All right, so this is a pretty nice visual, in my opinion, for how we can calculate and see the slope. So slope is the vertical change, or the rise, over or divided by the horizontal change, or the run. So we said it's a ratio, right? So we're comparing these two changes together. Algebraically, we have this equation that we can use when we have either a table or ordered pairs or a graph. And it's really important to note that points from the same pair are vertical. So see, we have y2 and x2 here, and we have y1 and x1 here. And it doesn't matter which is which, but you have to make sure that the values from the same ordered pair are vertical with each other. All right, these are the different kinds of slope that we can have. We can have a positive slope. So when you're going across your paper from left to right, you'd be going up a hill. A negative slope is if, again, we always go from left to right, you'd be going downhill. A zero slope is just horizontal like this. And then undefined is when you have this vertical line. And that's because with undefined, a horizontal change is 0. We can't divide by 0, so that is an undefined value. All right, so let's take a look at some examples and find some rates of change. So first we're going to look at a table. And when I use a table, how I find the rate of change, you can write it out as ordered pairs. I do this. So the difference there is 4, 4, 4. So what I'm doing is from 1 to 5, that's a change of 4. You add 4 to 1 to get 5. Or 5 minus 1 is 4. And then here, the difference is 2. 2, 2, 2. So my change here, and the x is our horizontal, right? So this is the horizontal. And then this is the vertical, right? The y is our vertical. So if I'm going to have my change in my vertical change, I can say change in y And that's what this means, change in y over the change in x. And that triangle is a delta, and it stands for change in. All right, so my change in y here is 2 over the change in x, which is 4, or simplifies to 1/2. Okay, so this is my slope. Determine if the function is linear. It is linear because the change is the same. That's what it means when it said that linear functions have a constant rate of change. The change is constant. It's the same between every pair of points. Therefore, the function is linear. So let me write that down. So the change is the same between all points, so it is linear. As the year goes on, we will see examples of nonlinear functions, but know that if the change is constant, then you will have a linear function. All right, this example. So again, I'm going to find the change. So here my x is changing by 1 each time. So that has a constant horizontal change. My y, my vertical change here is 2, 4, 2, 4. So this is not constant, right? My vertical change fluctuates. And if I write them as fractions, I would have 2 over 1 and 4 over 1, 2 over 1 and 4 over 1. But these are not all equal to each other. So the change is not constant, therefore not linear. Okay, not linear. All right, we can also find the slope from a graph. So I'm going to zoom in on mine. I know the lines are a little bit small, so it's a little bit tricky to see the points on yours, but go ahead and label them. So this first one is 1, 2, 3, -4, -2. So that's one of the points. And the other point is at 1, 2, 1, 2, 3, 4. Is at 2, 4. So when I'm going to use the points to make my slope equation, I like to label them. So I have x1, y1, x2, y2. Now I can use the equation that we had on the previous page. So y2 minus y1 over x2 minus x1. So now I'm just going to substitute in my numbers. So instead of y2, I'm going to have a 4 minus y1, which is -2. And I'm going to write a ratio to x2, which is 2, minus -4. 4 minus -2 is 6. 2 minus -4 is also 6, so my slope is 1. If you look back at the picture, as we go from left to right, the graph is going up, so it should be positive. Oh, sorry, let me move that up so you can see the work. All right, so we identify the ordered pairs, substitute them into our equation, and then simplify. So let's go ahead and do that for example B as well. So here we're going to find our ordered pairs. So 1, 2, 3, 4. So again, -4, and then 1, 2, 3, 4, 5, a positive 5. My other point here is 1, 2, 3, 4, and 1. Now I can see when I look at the graph, it's actually going down as I go from left to right. So my slope should be negative. All right, Okay, so it should be negative. I'm going to use my equation. I'm going to label. So this time I'm going to put this as x1, y1, and this as x2, y2, because it doesn't matter. It doesn't matter which one we do as long as we're consistent, meaning we put whichever one is x2 and y2 vertical from each other. Otherwise, you'll end up with an incorrect value. So now I'm going to go ahead and substitute. So for y2, I have 5 minus y1, which is 1, x2, which is negative 4, minus x1, which is 4. When I simplify, 5 minus 1 is 4. Negative 4 minus 4 is negative 8, which simplifies to negative 1/2. I said I wanted a negative slope, and I got a negative slope. So that's another way to check, is looking at the picture, should it be positive or negative, and what's happening. All right, the next one here, we can see it's a horizontal line. So by the picture, that should have a 0 slope. Well, let's look, let's prove it. So we can identify some ordered pairs. So this is at 1, 2, 3, 4, 5, 6, 7, negative 7, 1, 2, 3, 4, 5, okay. And I'll pick another point right here, which is at negative 2, 5. So when we use our formula, we get 5 minus 5 over negative 2 minus negative 7, which is 0 over 5, or 0. If you have a slope of 0, you have a horizontal line. Or if you have a horizontal line, your slope value will be 0. The next part, you are just identifying if the slope should be positive, negative, 0, or undefined. So here we have a negative slope. This, because it is horizontal, would have a 0 slope. This vertical line, this vertical portion, has an undefined slope. This one here, going from left to right, would be going down, so it has a negative slope. And then here, left to right, is going up, so it has a positive slope. So that's all you have to do for this one. All right, and then down here, it's more practice with finding the slope given points. So go ahead and label them x1, y1, x2, y2, and write out your fractions. So 8 minus 2 over 4 minus 3 will give us 6 over 1, or 6. And I'll even show you with this one, if I do it the other way. So I switch them. So now I'm saying that this is x2, y2, and this is x1, y1. So I'm going to write them the other way. So if I have 2 minus 8 over 3 minus 4, I get negative 6 over negative 1, which is still a positive 6. So as you can see, it doesn't matter which point you label as 1 or 2, as long as the ordered pair stays together. Okay, here, negative 6 minus 7, 8 minus 2, negative 13 over 6. Now for this one, we're going to leave it like this. Leave it an improper fraction. When you're finding the slope, slope should always be written as a fraction, or if it's a whole number or integer, it can be written that way, but it should never be written as a decimal when you're talking about slope. All right, now here we have fractions. That's okay, we can deal with fractions. So we have 7 halves minus 1/2 over 4/3 minus 1/3. So 7 halves minus 1/2 gives us 6 halves. 4/3 minus 1/3 leaves us with 3/3. 6/2 is 3. 3/3 is 1. So it simplifies just to 3. So that's how you find the rate of change and the slope.